Our first speaker of the day. Joining us from Denver, Colorado, we have Mamata Akella. Now, Mamata is to cartography as Mick Jagger is to rock and roll. So this is going to be a great way to start the day. So please help me in welcoming Mamata to the stage.
Okay, hello and good morning, and welcome to Locations day number 2. I'm just going to find a place to set this down. Okay, and I hope everybody had a really great day yesterday and yesterday evening. So as Flo mentioned, we're going to start today off talking about cartography. And of course, we're here for a conference about location intelligence. And as we've seen over yesterday and through conversations and just what we know being in this space, a lot of what location intelligence starts with is data. And this is raw data that we want to then turn into insight. So there's kind of a middle piece here that is really important to this process, and that's getting information from the raw data. And until we get information from the data, we can't extract the value or get the insight that we're looking for. And so yesterday we saw some different ways that this piece of the puzzle happens through spatial analysis, through CARTO frames, through different components of the CARTO ecosystem. And so I want to talk about the cartography part about all of this. And really what I want to demonstrate is how cartography is key to the exploration process, so the exploration of the raw data, and it's also key to the presentation of the insight. So it plays a key role in the entire, what we would call, data exploration process. Okay, so cartography for location intelligence. We've seen a variety of location intelligence applications, and there's kind of some themes that you can extract for the purpose of location intelligence applications. So I want to kind of go through a couple of those and then show how cartography plays an integral role. So a location intelligent application could be a tool for storytelling. So here we're looking at a map that is showing mass shootings that have happened in the United States from 2000 to 2018. And so right away, we can just go up to the legend that's on the map and see that the circles are sized by the number of fatalities, and the red dots inside of the circles are on the places, are inside of the circles where there's been 10 or more fatalities at that shooting. We can also see that as the design of the map has brought those larger mass shootings to the foreground, not to say that the other ones aren't important, but the ones that had 10 or more people killed. And so this map is telling that story. So using this symbology right away, we should be able to locate the mass shooting with the most fatalities, which is the Las Vegas strip shooting. Okay, so then if we look over on the right, we have other information associated with the current view of our map. We can see that the majority of these shootings happened with weapons that were obtained legally, and that the majority of the shooters had prior signs of mental health issues. But that's not the story that this particular map is telling. But if that's the story that we want this map to tell, we can filter the information to only show the shootings where the weapons were attained legally, and shootings that had shooters that had prior signs of mental health issues. And so now we see a different map. And because the symbology is the same, we already know what the symbols mean. In this case, we can see that the largest mass shooting, based on our filters, well, we'll see it, is Virginia Tech. Location, if I keep saying location intelligent apps, it's a lot to say. So LI, another use of a LI app is for situational awareness. We saw a few different examples yesterday of using location intelligence for some of the natural disasters that have taken place, especially last year. So this is a map that we made of Hurricane Irma. And this map was reading in, like if we go to look at this map, it's actually no longer there because the storm's over. But what we were doing is we were reading in live feeds from the USGS, the United States Geological Survey, that puts out, that updates data every 24 hours to basically, so people can use it to see where the winds are. So we're using wind speed probability data from them. We can also see that there's a hurricane track on here. And there's a Coroplus map kind of pushed to the background there that is using social vulnerability index data from the Center of Disease Control. So we're combining a couple of different data sources here. And because the map is dynamic, and because the storm was changing, this was actually a very unpredictable storm, we didn't know exactly what this map would look like day to day. But what we needed to make sure is that no matter where the storm path was or which counties were affected, that the map was interpretable right away. Especially in a case of situational awareness, you don't want people to have to sit there and try and figure out exactly the story that your map is trying to tell. So we can see on the right, and I couldn't even actually get to comparative screenshots very well because the map was happening so fast. But this is just an example of a couple of times I took a screenshot of the map, and you can see how the storm path is changing, the counties that are affected, different ones are highlighted. And so this map actually had no human updating it. We were using our platform and the open data from the USGS, and so this map kind of had to function on its own. LI applications can also be used for decision making. So this was a map that we made for the solar eclipse in the US. That was on August 21st. And so it was a big deal. It hadn't happened in the United States in a really long time. And we wanted this map to be a map that people could use to decide where they could go to see the solar eclipse based on some preferences. So different from the first map that we saw of the mass shootings, this map has just kind of symbolized only a couple of attributes in the data. There's this thing where, depending on where you are in the path of totality, what you see. If you're in the center, you're more likely to see a full eclipse. But as you change your position inside of the path, you see a different phenomenon. So what we want people to do with this map, and what they're most likely to do, is to start with where they are or where they wanted to go to see the eclipse. And then the map filters to update and show us, okay, now these are your selections in Oregon, and this person wants to be on the edge of the path. And so what we provide here is are the results of the cities ordered by the total seconds in totality. And so from this decision making, this person could say that they wanted to see the eclipse from Unity, or not Unity, Oregon, from, here it comes, Sweet Home, Oregon. LI apps are also used to share the results of an analysis. So this is a map that we made demonstrating some of the capabilities in our tool, CARTO Builder, which we'll look at a little bit in more detail. But as Flo mentioned, I live in Denver, and so this was a map that showed the development around a newly renovated, well, it was renovated a few years ago, a historic train station, which is Union Station, the black dot in the middle of the map. And then what we did is we derived some walk time polygons around Union Station, and because the area around this newly developed train station is developing and becoming more vibrant, we kind of wanted to see within a 5, 10, 15, 20-minute walk distance what the characteristics were. So we could see with this map, right away what we're showing is, okay, within a 20-minute walk distance, these are the parcels that have been developed, the polygons. And if we look at the legend, we can see that we're using kind of a multi-hue color scheme to show which were built in 2010 and sequentially going through all the way to 2017 in the darker pink color. So, but what if you're interested in looking within a 5-minute walk or a 10-minute walk distance? And instead of seeing the year, you kind of want to see what kind of parcels were developed. That first map can then become a map of what kinds of parcels have been developed versus what year they were built in. And I'm just going to have a sip of water, sorry. Okay, and what's really actually interesting is that data exploration now, where we are today with location intelligence and all of this on the web, and specific to the use of this, is that we have two different kinds of users. We have the person that's the author, which could be a data scientist, just a person interested in exploring data. But then we also have the map user. So these are two different people. So the map author. As a map author, you will probably get some data. This is, you'll start with some data. And again, we need to turn that raw data that's just telling us about something that's happened into that final insight. So this is some data that is that I found on the USDA. So the USDA website, and it's basically records of crop loss that happened in 2017 in the United States. So we can't really infer much from just looking at this table. Once we do, we could see in the table that there's an attribute that describes the kind of crop that was lost. But really, sometimes your first intuition is to just make a map and publish it. And so while this map is interesting, and we can see some patterns because we've applied symbology to one of the attributes, really all this map is just showing crop type by county. And we haven't actually told the story of any of the other attributes that are available to us. And so what you can use a tool like CARTO Builder for is to do that initial data exploration. So here we're inside of CARTO Builder, and we've added a series of widgets. And the widgets are used to summarize the entire table. So what happens is the widgets dynamically update as you are zooming and panning your map. So what the data summarizes at the national scale is very different from what it summarizes if you were zoomed in. And so we could see that drought was the cause for most of the loss, and that the crop that suffered most was wheat. And again, as I zoom, we can see all of these all of these widgets updating to the current extent. And this is so awesome, and it's a really great way. This is what I do myself all the time, is before I start making any map, I just add some widgets and I explore my data to find some interesting stories that we can then tell. And so once you get to know your data better and find the story in it, you can use those attributes and make a map not just of crop loss, but you can size the symbol by the amount of the loss and add some widgets that summarize that information, and now you've told a story, right? And then, as we saw in the first view of the data, there's so many other attributes behind each one of those points. So what might be a crop loss by county, by the amount of loss, if we actually wanted to see the cause of the loss, we can do that in the same map by using something that's called auto style. And so what I've done here is I've clicked on that teardrop button, and that's all of a sudden now made this a map of the cause of loss with the color and the amount of the loss by the size of the symbol. Okay, and so again, in this paradigm, data exploration is also possible by the map user. So this is the map that we just went through, and you could probably share this, on the internet or whatever, or you could share it with colleagues and have them explore it and find their own stories of it. And what's really, really cool is that this one map that you made can be a map that tells many stories. So if we wanted to highlight in a newspaper which crops were hit hard from hurricanes and rain in 2017, we can make a map specifically targeted to that question from that original map that we had made. Or if you want to filter further to show one category, in this case, drought, you can do that too. And what happens when you do this in a published map is you actually get a brand new URL that you can use. So you can imagine how many URLs you could come up with based on the different combinations of information that are in your data that you want to show. Okay, so this is today, and it's really, really exciting. And I don't know, just a show of hands out of curiosity, how many of you have taken advantage of the power of Builder in this way? Awesome. That's great. So, I almost feel like a lot of times when I make maps with Builder, I'm like, oh my gosh, I can't believe I just did this because it's just so futuristic already. But we're working with a technology for cartography that was built for base maps. So right now, when you zoom into a base map, whether it's a CARTO base map or a Google base map or an Apple base map or a Mapbox base map, what happens is as you zoom in, you get more and more information. You begin to get that additional information to put the place that you're at or interested into more context. And that doesn't happen right now for the data layer. So at CARTO, what we've done is we use CARTO CSS as our map rendering language, as our styling language, but CARTO CSS was developed for base map cartography. It was not developed for thematic cartography. So we've been adapting CARTO CSS. Some of you may be familiar with Turbo CARTO, and Turbo CARTO was created to take advantage of this dynamic nature of our platform. we have a very powerful and dynamic platform, and CARTO CSS in many ways can't keep up. So if you zoom into these pink and blue dots at different zoom levels, unlike the base map that's giving you more information, you're actually not learning anything new based off of the map symbology when you zoom in. And you can do multi-scale styling, but it's really complicated. You have to write a lot of CARTO CSS. If your CARTO CSS is not written in the best way, then your map can become very efficient and expensive to render. There's also a lot of advanced visualization techniques. We're seeing such awesome data coming in, and there's such a variety of data. And there are really cool ways that we can symbolize that data. We can borrow from data visualization and cartography. So all of these examples that I have up here, one of my hobbies is to try and make different maps, but it's also really complicated, again, with CARTO CSS. But this should be possible. This should be easy to do and available to everybody, because really what's behind any of these representations here is data. So this is data-driven symbology. And we should be able to take advantage of that data and visualize it easier. So that brings us into the future. And in terms of cartography, we need, So what's most exciting about cartography at CARTO for the future is the vector library that we've heard about a couple of different times this week. So specific to cartography, what we're doing is we understand the downfalls and or I should say rather, the pitfalls of using CARTO CSS for thematic cartography. Again, when it was meant for base map cartography. We're really thinking hard about how we can basically build a custom styling language for all of our users and really make the process of visualizing the data, all of the data that we're getting and all of the insights that we want to find in really compelling ways. So the most exciting part here based on, there's many exciting things, and we'll be hearing more about them, but really this multi-scale piece. So as I was showing you in the base map example, or in the CARTO CSS example, as we're zooming in, we weren't actually getting any more information. But this is an example of our vector rendering library. And so all we've done just to demonstrate is to show that as we're zooming in, two things are happening. Our symbol sizes are staying proportionate to the current zoom, and we're also changing the color. And this is to demonstrate the power of what's coming. Similarly, as we're zooming in here, you'll see these 4 dots there in the middle change color. And so, oops, I don't think I could play that again. But what was happening there was, as we're zooming in, the information was getting redrawn and re-symbolized based on the information around it. So instead of reading the entire data set, it's adapting to your current view and your current zoom. ¿Pueden pasar? Okay. Sorry, so that all anyways, I am not gonna, I actually don't want to talk too much about the vector library because my colleague Raul, who's the head of technology, is going to give a deeper dive into it and show some of the really amazing things and the thinking behind it. And so, but do expect us to start talking about it more and showing some examples and really enabling you guys to be able to do some of this stuff as well. And so that is all I have. Thank you.